morning, children. In today's class, we shall solve questions from the NCERT Exercise 4.5, and we shall be using all the previously known concepts, like we know how to find out determinant of a 2 by 2 or a 3 by 3 matrix. We also know how to find out the adjoint of a 2 by 2 or a 3 by 3 matrix, and all these concepts we shall use will be helpful to us in solving the questions. So let's get started with exercise 4.5. The exercise has got easy and direct questions. I'm going to take up here question number 2. 3 by 3 matrix is given. These are the elements of the matrix, and I'm naming the matrix as matrix A. We have to find out the adjoint of the matrix. So the adjoint of this matrix is transpose of some matrix. What are the elements of this matrix? Cofactors of all these elements. Now, by finding cofactors, we will ensure that these elements are special elements, and hence by finding the cofactors, the determinants will change sign. So let us find out here. Cofactor of 1 is 3. Cofactor of this element is 2 plus 10, which is 12, and hence it becomes minus 12. Cofactor of this element is plus 6. Then this element will have minus 1, and sign will change to plus 1. Then for 3 it is 1 plus 4, that's 5. And for this element it should be minus 2, so sign will again change to plus 2. This element has cofactor minus 5, minus 6, that's minus 11. This element will have 5, minus 4, that's 1, and its sign will change. This element will have 3 plus 2, 5. So we have found the cofactors. Next, let us transpose, and on transposing, what we get here is this matrix. So this way we have found the adjoint of the matrix. So next we are taking up question number 6. In this question we have to find out the inverse of these matrices if it exists. So we will first of all check that the inverse exists, and then we'll proceed to find out the inverse. So in the 6th question, a 2 by 2 matrix is given. Elements are these. Once again, let's call it matrix A. So we'll first of all find out here determinant of matrix A, and the determinant is minus 2, minus of minus 15, minus 2 plus 15, which is 13. It is not equal to 0. Because determinant A is not equal to 0, so we know that A inverse exists. If A inverse exists, what is the formula for finding out A inverse? A inverse is the adjoint matrix divided by the determinant. So here you can see that if the determinant is 0, the inverse does not exist. That's why we have mentioned that because determinant is not 0, so the inverse exists. And let us substitute values 1 upon determinant. Determinant is 13, and then multiply this scalar quantity to the adjoint matrix. Now for a 2 by 2 matrix, we know how to directly find out the adjoint. We can interchange the diagonal elements like this, and the off diagonal elements will simply change their signs. So it is minus 5 and positive 3. So this is the adjoint matrix divided by the determinant, and hence this is equal to the matrix with these elements. this is basically an optional step. We can leave our answer at this step as well. So next, students, we are taking the 8th question. A 3 by 3 matrix is given, which we are defining as matrix A, and the elements are 1, 3, 5, 0, 3, 2, 0, 0, -1. And we are again finding out the inverse of this matrix. So let us first of all find out the determinant A. The first row has got maximum zeros. Even the third column has got maximum zeros. I'll be expanding along the first row. So 1 multiplied by -3 into 0. This we are getting determinant A as -3, which is not equal to 0. Hence we again get to know that inverse of the element of the matrix exists. Next step, we'll find out the adjoint. And to find out the adjoint, we will again find out cofactors of these elements. Alright, now to find out the cofactors, let's once again start. This is -3. The next element will be -3 with a changed sign. The cofactor here is 6, -15, which is -9. Over here it is 0, so 0 is neither positive nor negative. For this element it is -1. For this element it should be 2, and hence sign will change. For the element 5 it is again 0. For this element it is again 0, and here it is 3. So the cofactors have been found. Next, transpose. -3, 3, -9, 0, -1, -2, 0, 0, 3. So it is advisable that you should first find the cofactors, and in the next step you transpose. Don't find out the adjoint directly by finding cofactors and transposing in the same step. There could be errors. So adjoint has been found. So next, let's find out the inverse. Inverse is the adjoint of the matrix divided by the determinant. Determinant is -3, and the element of the adjoint matrix this way. So multiplying each element by -1 by 3. This is 1, -1, 3, 0, 1 by 3, 2 by 3, here is 0, 0 and -1. So this matrix which is obtained is now the inverse of the matrix. So next question we are taking up is question number 12. So in the 12th question, a square matrix A is given with elements 3, 2, 7, 5. Another square matrix of same order with elements 6, 7, 8, 9. And we have to verify that inverse of AB is same as B inverse into A inverse. Now to verify this, let us first of all find out the product AB. So 3, 2, 7, 5 multiplied by matrix B. Both are square matrices of same order, so multiplication is easily possible. So this element is 18 plus 49, and this element is 24 plus 63. Here is 12 plus 35. Next is 16 plus 45. So here we get, this is 59, 67. This element is 47, this is 87, and 40, this is 61. So the product has been obtained. Now to find out the inverse of this product, we need to find out first of all the determinant, and the determinant is this multiplication of bigger numbers. So let's do a bit of rough work here. 742 plus 48, 36, 40. So the first number here is 4087 minus 81 into 47. So 7, 306. This is 30. 56 and 60 zeros is 32, 38. This is 87, sorry, 49, 4, 56, 67, 56. This will give you 4089. So we get here minus 2. Now since the determinant is not 0, therefore this inverse exists. Alright, and AB inverse would be equal to the adjoint of AB divided by its determinant. So determinant we have seen is minus 2. Adjoint, because it's a 2 by 2 matrix, we can directly find out. This is the product matrix, so interchange the diagonal elements and change signs of diagonal elements this way. So this is basically the left hand side that we have obtained. So I'll put this in a box, the left hand side. Now we shall find out the right hand side. Now to find the right hand side, we first of all need to find out determinant of B, and from there you can see it is 54 minus 56, so this determinant is minus 2. So this basically means that B inverse exists. Let us also find out determinant of A. Matrix A is written here. So 15 minus 14, which is equal to 1. Determinant A is not equal to 0. So this means that A inverse also exists. So right hand side is product of B inverse with A inverse. So I'll write down here the formula. What we are doing here is multiplying adjoint B upon determinant B with adjoint A upon determinant A. So we know determinant B is minus 2. Adjoint of B, once again we can find out directly, interchanging diagonal elements and changing signs of the diagonal elements. Determinant A is 1. So directly writing adjoint of this matrix, which is this. Now let's perform this multiplication. So what we get here is 45 plus 16 minus 35 minus 12. Then here we get minus 63 minus 24, and we get here 49 plus 18. So this is minus half, 61, this is minus 47, minus 87 and 67, and this is coming out to be same as the right hand side. So right side we have simplified, we are getting the same result as left hand side, hence we have verified the result. So next, moving on to question 14. Matrix A is a 2 by 2 matrix. This is given. We are given a matrix equation, A square plus this term is, this is 0 matrix, not 0. This is the given information, and we have to find out here values of A and B that satisfy this matrix equation, and then hence we have to find out here A inverse, right? So let's start from here. A square means matrix A multiplied by itself plus A times matrix A plus B times identity matrix of same order, and because on the left side we have got square matrices of order 2, so we know that on the right side we have a 0 matrix of order 2 only. So performing this multiplication, what do we get? 9 plus 2, 3 plus 1, here is 6 plus 2 and 2 plus 1. This is A square. Performing scalar multiplication, so multiplying each element of the matrix by A. Here also multiplying each element by B. And now I can write down directly also that sum of these three elements will be equal to 0. That's equation 1. Likewise, 4 plus A plus 0 is 0. That's equation 2. And the third equation that we get is 8 plus 2A is 0. And the fourth equation, 3 plus A plus B is 0. Looking at this equation, you know that value of A is -4. So this value we have found. Alright. You can cross check. Okay, before cross checking, let's substitute it in the fourth equation and find out A is -4. So value of B is 1. This also we have found. Once we have found the equations, we have basically used here equation number 4 and equation number 2. Two more equations are given. We'll just put these values of A and B in the first and the third equation. If the equations are satisfied, that means we have found correct values of A. So substituting here in equation 1, the left hand side, 11 plus 3 into A plus B is 11 minus 12 plus 1, which turns out to be 0. So values of A and B satisfy the first equation as well. Cross checking the third equation, in equation 3, 8 plus the left hand side is 8 plus 2 into A, which turns out to be 0. So both the equations are satisfied. Hence we have got values of A and B, value of A and value of B. Now in such questions, after we have found out values of A and B, we have to substitute the values in the remaining equations to cross check whether the values are correct or not. Suppose it so happens that the last equation is not satisfied, this condition is not satisfied, that means values of A and B have been incorrectly found. Alright, that is why we have to always cross check. Now after finding values of A and B, come back to this equation and substitute value of A, which is -4, and value of B, which is 1, this. So this is the equation now. Hence find A inverse. The word hence basically means to use this equation to find A inverse. In such situations, we can't use the formula adjoint of the matrix divided by determinant of the matrix, because the question uses the word hence, which means, once again, use the given condition to find out A inverse. So here let us post multiply. Please remember this is a 0 matrix. Post multiply by A inverse. Alright, so here is A square into A inverse minus 4 A into A inverse, identity matrix into A inverse, 0 matrix into A inverse. Because matrix multiplication is associative So we can write down this. I'm simply simplifying this term. A matrix multiplied by its inverse is identity matrix, and identity matrix multiplied by any matrix is A. So the first term simplifies to A. Here also, a matrix multiplied by its inverse is identity matrix. So just copying down the second term, it is this. Moving to third term, identity matrix multiplied by any matrix gives us that matrix. So that means the third term in simplified form is A inverse. And on the right side, zero matrix multiplied by any matrix will remain a zero matrix. So after post multiplying the given terms of the equation or the matrices of the equation by A inverse, this is the equation that we have obtained. Alright, now in this equation only, leaving A inverse on the left hand side, shift the other terms on the right hand side. So we get here A inverse is 4i minus A. 4i is this, and matrix A is 3, 1, 2, 1. So we are getting here so this means A inverse matrix is a square matrix given by elements 1, minus 2, minus 1, 3. So this way we have found A inverse using the given condition. So there are more questions in this exercise which are similar kinds of questions. If you try out these questions, you will definitely get the solution. So please try them out.